So we didn't get to this problem yesterday, but I want to go over it and see how you can do. What is the general solution to dy dx equals 2yx plus yx squared? So if you have dy dx equals 2yx plus yx squared, what's the very first thing you have to do? You have to, what's it called? Separate the variables, right? Okay, so we have to get all the y's on one side, all the x's on the other. So what can I do with this to make it workable? Okay, true. I'm going to factor out a y. Just so you can see the math behind it. That's y. All right, multiply by dx, you got dy equals y times 2x plus x squared dx, right? And then we'll divide by y. How do I want to write that over here, though? I don't want to necessarily put dy over y. 1 over y dy equals 2x plus x squared dx. Again, like we talked about yesterday, you have to make sure that dy is being multiplied to the thing we're talking about, not added. Same thing with dx. It has to be multiplied to everything. Okay? Then we integrate. What's the integral of 1 over y? That is natural log of what? Absolute value of y. So we end up, what's the integral of this? X squared plus 1/3 x cubed plus c. And we're looking for y. So what do I have to do here? So we're going to rewrite this as exponential. So it's going to be absolute value of y equals e to the x squared plus 1/3 x cubed plus c. Where do you get the absolute value from? Because when you take the antiderivative, you always put absolute. Oh, what do you do with it?
Yeah, the negative.
Okay, can y, or can this side ever be negative? Well, this is automatically positive because that says absolute value. But look at this side. Can this side be positive or negative? This has to be positive because e to any number is positive, right? So that means this answer is always going to be positive anyway, so you can get rid of it in that case. Okay. Again, something we will discover more and more as we go along about that absolute value thing. Let's see if my answer matched this. So factoring, I don't know why I called this a challenge. It wasn't that much of a challenge. Oh, that's why. Okay, so this is true. But if it's a multiple choice question, I think that's why I put it up here, is because the form of the answer did not match this answer. So why did that C get to go out front? Well, yeah, but how did this C end up out here, if that's how you want to look at it? Remember, what's the rule we talked about yesterday? This is e to a sum, right? So this is the same as saying e to the x squared plus 1/3 x cubed, and then times e to the c. Isn't it? Because if I say 3 to the 4th times 3 to the 2nd, that's the same as saying 3 to the 4 plus 2, right? Okay. So since I'm adding all these, I can break this apart. And what's e to a constant? Because e is a constant, it's a constant, right? So that's why it's capital letter C. So we can move this. This is just a constant value. Constant times e to the x squared plus 1/3 x cubed. It's the same answer. Is this C the same as this C? No, but that's why we use capital letter C, because it's just whatever constant we have. Okay? No, I just write small.
If you ever
must be wrong.
On your test, I'm going to see all this little writing, and then I'm going to see this giant C next to everything. I didn't say that. All right. So let's get into today's stuff. So we're going to do a problem that applies the idea of separation of variables. It deals with the idea of exponential functions and decay rates and growth rates. All right. You guys remember that at all from Algebra 2 analysis? The rate of decay and the rate of growth with exponential, right? You'll see a connection hopefully today, okay? Can I go on? This problem I'm about to give you, I would rank up there with one of the more difficult problems. Not because of the calculus, but because of interpreting what's being said. Okay? Let's take a look at what this means. Okay, so exponential growth, the rate of change, what's an equation that would represent rate of change? No. Rate of change is what? dy dx, right? Because it's a rate. dy dx is a rate. So the rate of change in regard to any exponential growth, and this is why exponential functions are so important, because they're derivatives that produce a very clean answer, in fact. Okay? The exponential growth is always proportional to the amount present. What does that mean? What's proportional mean? It may be a fraction. It could be proportional and still be bigger. Like if something is 3 times bigger, the constant that we're multiplying everything by is what? 3, not necessarily a fraction. So if I say something is proportional to something else, so if x is proportional to y, what's an equation that will relate these two values? You could say x equals, cy, constant times y. What did you say? Okay, so you just plugged in a value for c2. So if I plug in x equals 2y, that would mean that x is twice as big as y, right? So this is causing it's causing this value to be bigger, right? How would I make this value smaller? This would be less than what? Less than 1, right? So a constant of proportionality, when we're talking about rate of change, though, looks very similar, but it cleans things up pretty nicely. Okay? So a differential equation, this is what it is, dy dx, is directly proportional to the amount present if you can write it like this. Dy dx equals a constant times y, where k is what? K is a constant, but what kind of value is it? Not just constants. What? A whole number, maybe? Well, that's dealing with proportionality, like in similarity. But this is when k is greater than 0. You'll see it in a second. In fact, let's kind of go over it. Let's say I wanted to solve that differential equation. Dy dx equals k to the y. So this is exponential. Can you see that? Can you see an exponential equation in this? Not really right now. How would I solve this differential equation? Separate the variables. Remember, k is a what? Constant. It's not a variable. So how do I separate these? So dy dx equals ky dx. Now what? Divide by y, so you end up with 1 over y. dy equals k dx. Are you guys okay with this? Now what do you do? Now what do you do? Integrate it? So what's the integral of 1 over y dy? Natural log of the absolute value of y equals, what's the integral of k? Kx. See? Okay. Now again, what's the goal here? To get y by itself, so how am I going to write it? So it's going to be absolute value of y equals e to the kx plus c. Remember, we just talked about how to rewrite that. The absolute value of y equals e to the kx times e to the c, right? So we could say absolute value of y equals big C e to the kx. Well, that's a big C also. That's a good question. Can this be negative?
Yes.
If C is what? Negative. So it does, that would be assuming you can only make that positive, or you can only make that just y if that's a positive.
So then wouldn't the other one?
That's a good point. That's a good point. The way we had it before, with C up here?
Is it the same thing?
Okay, fair enough. Maybe we can. E to the C is always what? No, if C is negative or not, right? That's always positive. So that means when I rewrite this as just a constant, this must be positive. So you're right. This can be written as just y. Okay. Now, hey, look at that. It's an exponential function. Right? So this is an exponential function with a rate of growth, a growth rate, right? Because k is positive, greater than 0, right? You guys remember this from rate of decay and rate of growth? Growth rates? Okay. Well, it would end up being the same thing. If k was greater than 0, this would be growth. If k was less than 0, then you'd have a negative exponent and it would be decay. Just going back to your algebra 2 stuff. You don't remember that? If I said e to any negative value, what does that graph look like? Y equals e to the negative versus y equals e to the positive value. This is like that, right? What's negative? Plug in some values. Plug in 0. 1. Plug in infinity. E to the negative infinity is e to the 1 over e to the infinity. So 0. So it's not 0, it's approaching 0, right? Plug in a negative number. E to the negative infinity is e to the infinity. So we get the kind of the reflection of it. So you can see the function's decaying. It's decreasing, and this is increasing. Does that make sense? Okay. So you can see this is kind of cool. Which one's easier to look at? The y function or the dy dx function? Dy dx is easier to look at because it's just a constant times whatever the y value is, not whatever the x value is. Okay? If k is less than 0, then we say that this is a rate of decay, right? A decay constant less than 0. Are you guys okay with this? No? Doesn't look like it. This does not ring a bell from algebra 2 at all? Not that. Look, not that per se, but if we go to this form, if we go to the exponential form, if k is positive, you see an exponential function that's increasing. If k is negative, you see an exponential function that's decreasing. So, what do we call it? This is a growth, and this is a decay.
I never took it.
No?
I took it. I just had to.
Excuses. Okay. Here's the problem. The intensity of light. So you jump into the ocean. The idea is when you jump into the ocean, the deeper you get, the deeper you sink, the darker it gets, right? So there's a point somewhere along the way where you get deep enough and you can't see anymore. You know what I'm saying? That's exactly what this is talking about. Okay? So you're jumping in the ocean. How much can you see at the surface of the ocean? Everything, right? 100% visual acuity, right? You can see everything. The moment you start going down in the water, your vision starts getting, not, I wouldn't say blurry, but getting worse, right? You can't see as far, basically, okay? Because the light that's coming into the water is dissipating. Does that make sense? Okay? So we have, it gives you the equation. It says dl dx is equal to negative KL. What does L represent?
Why?
The amount of light. X represents how deep you are in the water, okay? Because that says negative KL, what does that imply? Is this a growth or decay? It's a decay, and that makes sense. The light is decreasing. The intensity of light is decreasing as you go deeper. So the intensity of light is cut in half at 18 feet deep.
What? That's where I got lost.
So that means when you get 18 feet down, how much light is present? Half of what it would be if it was on the surface, okay? If the intensity of light gets below 10% of the surface value, then the diver needs to use artificial light. In other words, he needs to turn a flashlight on. A waterproof flashlight. Okay. How deep can they go without artificial light? Okay. So here's what I want you to do first. You have you have a differential equation, right? dl dx equals negative KL, right? Solve that differential equation for me. Done? Come on, solve it. Okay. So differential equation, dl dx equals negative KL. How am I going to solve it? We just did one similar to this. Is it like this? It's okay. It's okay. Sorry. Marilyn. Keep going. How am I going to solve this? Separate the variables. How are we going to do it? Multiply by dx and divide by L. So you get 1 over L dl equals negative K dx. Okay? And then we're going to integrate. What's the integral of 1 over L? Natural log of L equals kx plus c. Now I should probably put absolute value around L, but light intensity, think about it. Can the intensity of light be a negative value? No. The natural log of a positive value here, so it's just L.
If it's really dark.
All right. So now we can solve for L because L is the dependent variable if we want. But before we do that, what did I tell you about differential equations? It's easier to find C before you solve for L. How do you get C? You need an initial condition, and this is where it gets a little weird. So far, this was easy, I hope, right? Okay. The initial condition, well, let's read what else it says. It says the intensity of light is cut in half at 18 feet deep. What could you say about that? Okay, when x equals 18,
Y equals 1/2.
well, I'd say L equals 1/2 of what?
Of the initial condition.
So it's like an arbitrary value.
L of 0.
Right, okay, so you don't know what the, it says it's half, what? Half of the surface, right?
Yeah.
The surface level light. Well, how bright was the surface level light? We don't know, so we'll just call it L of 0, as in when x is 0, that's kind of the initial condition there. When x is 0, what's L's intensity? What's light intensity? We don't know, but we're going to call it L of 0. It's the light intensity when x equals 0. You guys get that? When you don't go down anything, then your light intensity is full bright. I don't know what that is. I don't know what the value is. Yeah, I could call it whatever. But I do know it's the initial light intensity. The intensity of the light when we have not gone below water, basically. When we go 18 feet down, the light intensity, whatever it was, is half of what it was on the surface. You guys okay with that?
Yes.
So now we can plug values in. Oh, wait, real fast. It says, if the intensity of light gets below 10% of the surface value, so when does that occur? If the intensity of light gets below 10% of the surface value, so what would that be? 0.1 of the L of 0. Does that make sense? And that's the question. It says basically how deep are you when the surface level of light, when you have 10% of the surface level of light. Okay?
So we'll solve for that in a little bit.
So our goal is to figure out this x value at this point, but we need to figure out c by using these values. Okay? So we got natural log of L, I'm going to just rewrite that equation, equals negative kx plus c. Okay, what's the easiest one to plug in? That one? So it's the natural log of L of 0, right? Equals negative k times 0 plus c. So in other words, c equals the natural log of L of O. You guys okay with that?
Yeah.
Do you know what the light intensity is at 0 feet? No, but whatever it is, that's the constant value. So now let's plug it back into our equation. We end up with the natural log of L equals negative kx plus natural log of O. How many variables do I have now? 1, 2, 3, 4. Well, let's keep going. Maybe let's plug this guy in.
Mr. Randy, are we gonna get like a number?
Yeah.
No way.
We're gonna get a number from that.
Yeah.
Get a number out of all this. Out of all these letters.
Watch. Watch.
Numbers?
Watch. Let's plug this in. What do we get here? The natural log of 1/2 LO equals negative K times 18 plus the natural log of LO. That actually cleaned up a lot. Because now how many variables do we have? 2. But I can simplify this. Let's subtract natural log of LO from both sides. So we get natural log of 1/2 LO minus natural log of LO equals negative 18K. Anything click in your brain yet?
Okay, can you like do the properties?
You got a natural log property here. So I can rewrite this as the natural log of what? 1/2 LO divided by LO equals negative 18K.
Okay, wait, time out. Go over some.
Okay.
Divided out by.
Be patient. Just want to make sure everybody gets that. Are you guys okay with this property here? Okay. Now that I've got 1/2 LO over LO, that just reduces to natural log of 1/2 equals negative 18K. And what is the natural log of 1/2?
A number.
It's a number, right?
Isn't it log of 1? Isn't it 2? Isn't it?
No.
No, wait,
No, it's not natural log of 1 over natural log of 2.
no.
I don't know. What did you say? Okay, let's solve for K because we've got to figure out what K is. K ultimately equals what? Natural log of, I'm going to put 0.5 here just to make life easier. Divided by, I'll put the negative out front though. Okay, we're getting there. Now we can take this and plug it into our equation here.
Wait, why
So
not?
what's that going to say?
Can you explain why?
Well, because remember, this is our particular solution. We just need to figure out what K is so we can keep going. Okay? So that's going to say the natural log of L,
Oh, we're finding X.
yeah, equals negative K. What's K? K is this. So it'll be negative, well, it'll just be positive then. The natural log of 0.5 over 18, and then X plus natural log of LO.
Scrap the negative.
No, because that's negative K, and that's already negative. All right. Now I can rewrite this as an exponential function, but I'm looking for what's happening at a specific point in time, so I don't need an equation. I'm looking for the depth. I'm looking for the depth that you are when the light is 10% of the original light intensity. So what do I have to do with this? With this. So this be the natural log of 0.1 LO equals the natural log of 0.5 over 18 X, and that's what we're looking for here, plus the natural log of LO. Are we okay with that? Now we got to solve for X. Subtract natural log of LO. So equals natural log of 0.5 over 18x, right? So natural log of what? That'll just be natural log of 0.1, right? Equals the natural log of 0.5 over 18 and then x. It's easy now. What now? So 18 natural log of 0.1 divided by natural log of 0.5 equals x. There's your answer. Get your calculator out and figure that out. So you're typing that in your calculator, what do you get?
59.7.
59 point what? Okay, and the units on this? Feet. So what is this saying? It says you can go down in the ocean approximately 60 feet and still see enough to kind of get by. Basically, you could see 10% of your normal vision.
Was this real application or was this made up numbers?
I don't know. I got it from somewhere. I assume it's reasonable. Yeah. The only made-up number in here is maybe when x is 18, you're cutting the light intensity in half. So maybe that happened, and I'm sure that depends on what part of the ocean you're in. If you're in Hawaii versus in California, in Hawaii you have clearer water, and so you could probably go down deeper and still have half light intensity. Maybe.
Is this worth like 50 points?
All right. Shh. No, let's hope it's worth 1 point because you're probably going to get it wrong, and you don't want 50 points minus, right? Yes. Yeah, it says how deep can they go without artificial light? So they can go until they hit 10%. All right. You're going to take an L? Yeah, you should probably bring a flashlight if you get below 59 feet. L is light. You take an L.
I'm going to take an L. I'm
Yeah.
going to light.
Yes. There you go.
I see what you did there. That was clever. I like it.
Because we defined L to be light. All right.
That was clever. I'll give you that. It was clever.
Perfect. You can get this done. Okay, you guys try this. I'll help you out with this. What is a differential equation, dy dx, that is directly proportional to y squared? What did I say about directly proportional?
Constant.
There's a constant. You can write it as.
dy dx equals constant y squared.
That's it. Okay. Well, what is the differential equation where it is directly proportional to y squared? So it's just y squared times some constant value, right? Okay. Solve that.